Welcome back. You're watching NewsX. I'm Uday Pratap Singh. Our big focus this hour. The Indian Space Research Organisation is gearing up for an ambitious leap in space technology with the launch of its space docking experiment, SpaceX. The mission is scheduled to launch at 9:58 p.m. today from the Satish Dhawan Space Center in Sriharikota using the trusted Polar Satellite Launch Vehicle, PSLV C-60. Now, SpaceX mission involves the deployment of two small satellites into the low Earth circular orbit at an altitude of 470 kilometers per hour. The primary goal is to test and demonstrate the technology for rendezvous, docking and undocking of these spacecrafts. Why is it then important? Well, it enables as astronauts or robotic systems to refuel, repair and upgrade satellites in orbits and more. By mastering this technology, India is seeking to join the exclusive club of countries currently limited to the United States, Russia and China that possess space docking expertise. Before we go across to our guests and understand the significance and technicalities of this mission, let's quickly understand what the space docking and specifications are of this mission. Well, let's explain that for you, of course, in more detail and quickly going, of course, across to these big developments, of course, coming in regarding this ambitious mission. So, the ISRO SpaceX mission will be using the PSLV C-60 lifting off at about 9:58 p.m. as I told you earlier, IST today from Sriharikota. The ISRO mission, of course, once it has lifted off, will be deploying two identical satellites, SDX-01 and SDX-02. You can see, of course, in the form of a description, of course, an animation, how they were going, of course, forward into space. Now, each satellite weighs about 220 kilograms and they will be orbiting about 470 kilometers above the Earth level. And attempt to dock two satellites orbiting at speeds of about 28,800 kilometers per hour is going to be made. Also, both the satellites must be maneuvered to reduce relative velocities to 0.036 kilometers per hour. That's, of course, a specific speed which is needed at the time of deployment. SpaceX will be demonstrating docking and undocking capabilities between the satellites as well. And the two satellites designated Chaser and Target will merge to form a single unit eventually as well. They'll be locking into each other, as you can see, of course, over there. Key objectives include performing precision rendezvous and docking maneuvers as well. And of course, the key objectives also include validating power transfer between docked spacecraft and also operating payloads with about a 2-year lifespan for them. Also, SpaceX will be using PSLV's fourth stage, POEM-4, for the experiment as well. That's also something that will be used. And the stage will carry 24 payloads from academic institutions and startups as well. Now, the process of bringing two spacecrafts together in orbit is, of course, space docking, the maneuver that will be carried out by this, and we hope that will be successful. It also involves a series of precise maneuvers to achieve control and stability between the two vehicles. It's, of course, a pretty specific process of integration. It also allows for the assembly of large space stations, also the transfer of crew as well as supplies in space. It enables astronauts or robotic systems to refuel, repair as well as upgrade satellites while in orbit. And it extends the astronaut or robotic system to extend lifespan, and also it reduces space debris as well. Now, it's essential also for transferring samples collected from other celestial bodies. That's also something that makes this important. The key step 1 is, of course, rendezvous, as I was telling you earlier. Two spacecrafts approaching each other in orbit, gradually reducing the distance. And this phase, of course, requires precise calculations and maneuvers to ensure a safe approach. Now, key step number 2, of course, is docking. Once the spacecrafts are in close proximity, they establish a stable connection, which is very, very important. Also, this is done using docking mechanisms such as clamps, latches or berthing rings as well. And this process often involves a series of soft contacts, also adjustments to align vehicles eventually as well. Now, the spacecraft, of course, finally in the berthing stage and step, may further integrate opening hatches to allow crew and crew transfer as well. Now, also the additional procedures such as leak checks are also done in this stage and step to ensure a safe environment. So, of course, all of this will have to be tick marked and done successfully for the final aim and objective to be achieved. Wing Commander S. Sudhakaran is joining us live, former Indian Air Force officer. We also have Group Captain V.N. Jha, senior scientist, live with us. Ram Srivastava, former ISRO scientist, is also joining us now live. P.K. Ghosh, space strategist, is also live with us. P.K. Ghosh, let me begin with you first. How important is this mission and its strategic objective?
I think this is an incredible step, because the first thing is that it will set us as one of the fourth nations, apart from US, China and Russia, to get this technology of docking and undocking. And if you look at the future, this is the technology that we will require for many of our future space projects, including to a certain extent the Gaganyaan, though we may not have too much of docking and undocking there. But even if we are going to go to the International Space Station, it's going to be one of the most important technologies that are going to be used for the Bharatiya Antariksh Space Station that we are planning for the future. It is going to be an important technology for getting the Chandrayaan 4, for getting lunar samples of the regolith bath. So all this is that this is a crucial technology that we have to master, and I'm sure we will do it. Just one more point. This is not the only, this of course is the most visible technology demonstrator that we are doing with this Poem 4, but please remember that there are 24 payloads with Poem 4, 10 of the ISRO and 14 of the non-governmental enterprises which are going to be there. So while we are focusing on this docking and undocking, which like I said is the most significant one, but there is a host of other experiment technology demonstrators, etc., that are attached to the single flight. And I am sort of really looking forward to seeing that all these payloads, especially, of course, the docking and walking one of SDX-01 and 02 chaser, as well as the target, comes through. But I'm equally expecting that all the other payloads will fulfill their aim in being a big success.
Okay, let me in fact now take that across to Ram Srivastava as well. Ram Srivastava, now why is this crucial? This liftoff today and also deployment, this first ever space docking reportedly by ISRO, if it is successful, and we hope it will be, how big a feat will this be, and why is this important?
But there is no question of if it is successful. It is going to be successful because we have already tested all the pros and cons in the laboratory, and we have tested the hardware and software. The only thing is this is to be done in zero gravity, and the spacecraft will raise 2 satellites along with others also in the same orbit, though it will be just 470 kilometers above the Earth in the circular low orbit, and it will release 2 payloads of each 220 kilogram each, and they will be simultaneously at the same time they will be released, and gradually one will be known as the tracer and one will be the chaser. One target and other is the chaser for that. And gradually their distance will increase up to 20 kilometer. Then the chaser will start its propellant and it will be running the same orbit in which the target is moving, and gradually they are reducing the distance, and when the distance is reduced the sensor will work. The laser guided sensors are there, and the chaser will also having the reflectors of the, and automatically manualing the algorithm is just like it will reduce the speed up to 7 per second, and they will just docking there. Once they are docked, that is going to be very successful. It has got multiple applications. The first application will come in our future space shuttle, and at present this can also be used. This is one mission that in future those big satellites which are moving around the earth, they are now not working because of the fuel is not there. So once we can develop this technology that the running satellite can be tracked in and can be chased and can be docked there, then this experiment will show how the electrical power will be transferred from one satellite to another satellite, or how we can give oxygen to the other dead satellite. So this is going to be very remarkable. For the first time in the history of space science, this type of experiment is being done, how to revive the dead satellite. That application is of future, not at present. At present, the accuracy of the docking and docking is very, very important. Obviously, as our learned expert already explained this particular thing, that when we'll go at the moon and we'll bring the sample, then sample will be transferred, and how we are going to transfer that particular mechanism, this is one step ahead. So I am very much hopeful that for the future progress of our space mission, this is going to be the landmark experiment of testing our hardware as well as software, and I am very much sure that this is going to be very successful, because we have already tested all the pros and cons in case of this thing is not working properly, how we can correct it. All those parameters are being feeded in our programming, and in future this is going to be very successful, and we are proud that the new year will be bringing one good news, that we are among those four countries where we have got this technology of our own. The peculiarity is this technology is exclusively Indian scientist technology. It has to do nothing with the other technologies which are being developed by Russia or America. Had this is successful, Sunita Williams would not have been hanged in space for such a long time. They are still waiting for that event when she can come back to the earth. But here we are taking even those consequences into our account, and that way of locking and delocking is very, very important.
Okay, let me in fact take that across to Group Captain Jha as well. Group Captain Jha, what are the stages of SpaceX mission that you're going to be keeping a close eye on, and what makes this mission so important for ISRO?
Thank you, Uday. It's a great sort of technology demonstration that we are going to have, the ISRO to have. Imagine if ISRO has to send a spacecraft to the International Space Station. It's surely International Space Station, if I may show to your viewers. International Space Station is about 400 plus kilometers above the Earth's surface. And when we send that spacecraft, one part of it, the payload in which the crew or the suppliers are there, that will have to go and exactly go and interface with the space station. Now this is a very tricky business. No, the universe is phenomenal. The 3D orientation therein is something which taxes the maximum of the technology that goes into the craft. Now we have most of us, we have seen how SpaceX they had sent their Crew Dragon It is absolutely automated. It goes aligns with the International Space Station and then gradually closes in and then docks it. In the docking also, it pushes there something, a plunger, and then it is locked, head in situ, and then the other things happen as our co-panelists were telling you. It's a very tricky thing. Now, what ISRO is going to do is, if I may try to show to your viewers, just imagine, this is the target and this is the chaser. Now, these are going to be deployed somewhere in around the same inclination, almost in the same orbit, maybe slightly misaligned, and then the chaser will have to go and absolutely at the speed that you mentioned, about something around a few millimeter of the speed, the forward speed. At that, it has to go and sit and dock and lock in there. Now, it's a huge asking. Newton's third law is fully here in the motion. Uh, in this case, of course, what ISRO is going to do is, it is going to release both target and the chaser almost in the same orbit, around the same thing. Now, think of when SpaceX sends its new supplies. It goes all the way from the Earth and tries to align itself, and finally it has to go and dock. Now, all these are absolutely precision, technology. What happens if it goes and hits slightly harsher? There could be damage to the plunger. There could be damage to the other things. Here, in this case, of course, ISRO will have slight bit of problem because both are light objects. Both are 220 kg. If the hit is slightly, harsh, the target will be pushed forward. So there are a bit of intricacies in this, but the whole aim is that in the zero gravity condition, how the chaser closes onto the target in the 3D atmosphere that it is there. In addition, it must not roll in either way. In case if it misaligns or rolls in either of the axis, then again there will be no interface, there will be no docking there. So all these things will have to take care of it. This is the very first step. Both target and the chaser are going to be released in the same orbit. It will be comparatively easier process that I can foresee. But this application will be, of course, one is the international, our own space station, and in case if Chandrayaan 4 tries to also bring some samples from there, then what happens? The entire spacecraft what goes to the moon, the main orbiter will be orbiting around the moon, and the lander will go to the lunar surface, gather some samples, and again ascend and interface with this orbiter, what it is there on that, go inside the orbiter, and then that the heat shield of it will be closing onto that. That entire things now will be sent from there, or will be coming from there, oriented towards the Earth. It will make the re-entry. One small correction if I may tell you, that velocity of this chaser and the target is about 1700 miles per hour. That is about 7.8 kilometers per second. That's a phenomenal speed. That's the phenomenal velocity at which it is there. So it is quite tricky. We know, the rocket technology is not something not very easily understood by many of us, even us. But then ISRO does it. ISRO keeps on doing it. Some part of it, ISRO has already been doing it. All the satellites, long duration satellite, already have this cryogenic engine within it. Small engine is there, which keeps on maneuvering its. All satellites go through the decay, velocity that slows,
Yes.
and the satellite starts falling back. So it has to be boosted up again.
Right.
So that is how it is there. ISRO already has this technology. I don't foresee much of problem in this. Wish ISRO all the best, that everything goes well.
Okay. Wing Commander Sudhakaran, come in here on the strategic advantage that we will get post the successful completion of this mission? What makes this important? Also, the complicated different stages of SpaceX that you're going to be keeping a close eye on.
There are a lot of takeaways from it, but having said that, we have to understand one thing. See, we are no longer another pushover country, which we used to be a decade back, or if I have to say. So, in this exclusive club, we are already 6 decades late. Remember, the US and the Russians did this way back in the 1960s, where we were grappling with our poverty of sorts. China did it almost a decade back. So better late than never. We have good sense prevailing in the country. We have the right leadership, and we are pushing our frontiers forward. And then we are arriving at the clubs where we were an outsider, not even an outsider to tell you. So coming to this specifically, space docking is a pinnacle of precision engineering. My co-panelists have already explained in minute detail about how these works. It requires mastery of orbital mechanisms and real-time decision making, because any small variation at any point of time can actually cause chaos. And it is very important to master this, because this will set the foundation for the Bharatiya Antariksh station that we are planning. And that is very critical, because any future war, now that we talk about, will be dictated by the space to a large extent, because the space-based surveillance as well as the air defense from the space is going to be very, very critical for you if you are really looking at taking on the behemoths, like China, or even for that matter, Russia or the Americans. So this is very, very critical, not only from this aspect, but also when you look at, venturing into deep space, wherein we will have a lot of missions, the Martian missions, or to stake our claim in the lunar territory, which is also going to be of vital significance in the future to come. This is a very, very crucial technology which we need to perfect, which we need to master, without which we will not be anywhere of our own. Of course, we can be dependent on somebody's shoulders to be able to, go home. But mind you, as the third largest economy in the world, it's economy that matters. So any future war will be for economic gains. And if we have to stay there in that club, we need to have a technology excellence matrix that is built on our own capability. And to that extent, ISRO has done a commendable job. We are breaking new frontiers, and this is one amongst them.
Right.
Of course, I lament that we are late, but then we have woken up late. That's our reality. The only thing that I pray in the years to come is we continue to stay awake and then, conquer new frontiers.
For more such videos, subscribe to the NewsX YouTube channel, hit the bell icon.